All right, guys, we're going to go through the notes and just keep track. Make sure you draw and write questions over to the side and circle or highlight anything that you might have questions on for tomorrow. Here we go at the beginning of notes. All we're going to talk about on this set is what happens when we change m. In our slope-intercept, y equals mx plus b. What happens when we change the value of m? So let's just go through here and get started. Okay, it says pay in more charges $25 per square foot that is painted. Draw this relationship. So we have a graph. So we're going to draw $25 per square foot. $25 per square foot. So I'm going to say my x value is feet. And over here on my y value, I'm going to have cost. It costs $25 per square foot. So 1, 2, 3, 4, 5. That's enough. And then we'll go up. Okay, we got the origin, 0. And we got 25, 50, 100, and 150, and 200. All right. So in this problem, the first A says, what is the slope? What is the slope? Well, let's look at this. If we start at 0 and we go 1 foot, that's going to be $25. 2 feet, that's going to be 50. 3, and you can see the pattern that develops, and we have our graph. Okay, we have our graph. Now, what is the slope of this line? What is the slope? Well, the slope is going to be 25. I went up 25 over 1. Up 25 over 1. Up 25 over 1. And so forth. What does this mean? Well, it means that each time it costs $25. $25 per square foot. What is the number for the y-intercept? Okay, y-intercept. Let's look at our graph. Bam, right there. It's 0. So it is 0. What does that mean in this situation? Well, in this situation, that means we're starting with $0. Starting with $0. All right, the next part of these notes talks about proportional relationships, and you can read the definition here. It says a proportional relationship between two quantities is one in which the two quantities vary directly with one another. One item is doubled, the other is also doubled. Because of this, it is also called direct variation. This is a proportional relationship. Can be seen on a graph where the slopes of a straight line is positive and the line goes through the origin. The slope represents the constant of variation, and the equation for the line can be written y equals mx or y equals kx. So what's going on here? A proportional relationship is a line that goes through the origin. So the two things that it is, it goes through the origin, okay, and it's positive. So it's going to have a positive slope, and it goes to the origin. If that is true, this is a proportional relationship, and the slope is a constant variation, and we'd have the equation y equals mx. Okay, let's look down here. And is this relationship proportional? We're going back to what we just did. Is it proportional? Is this proportional? Does it go through the origin? Yes, it does. Is it positive? Yes, it is. So yes, this is a proportional relationship. And the evidence is positive. The slope is positive. And it goes to the origin, like we just said. Okay? F says draw a new graph on the grid above to represent the change in the slope to 50. So let's go back to our graph, and it says, what if the slope was changed to 50? I'm going to change colors. Slope was 50. We would go up 50 over 1. There'd be a point right there. Then we'd go up 50 over 1. And we would go up 50 over 1. And we would have that line right there if our slope was changed to 50. Okay? What has happened to the line? So look at your graph. We changed the slope to 50, and here was our new line. Here was our old line. What changed? Well, this line is steeper. And your options are either get steeper or it gets flatter. So right here, it gets steeper. What does that mean for the guy that's painting here? Then what it means is that he earned more per hour. So each hour, he made more money. Okay, and then it says draw a grid that if we change the slope to 10. So let's go back up here and change it to 10. So here's our graph. I'm going to change the colors again to green. Let's say we go up 10. So if I went up 10, that's between 25. It's going to be somewhere right in there. Again, if I go up 10, it's going to be at 20. It's going to be right there below 25. And if I go up again, it's going to be at 30, right there above 35. If I go up 10 again, it's going to be at 30. And our line is going to be flatter. If we lower the number for m, if we lower the slope, so in this case we went from 25 to 10, the line is going to be flatter. The line is going to be flatter. And what does this mean for our guy that's painting? It means that he earned less per hour. All right, the next side of your notes. Go back to the top here. It says the parent function, and the parent function. Let me change it back to red here. The parent function for a linear equation, if you remember, the equation is y equals x. And I went ahead and filled in our table here. So if our equation is y equals x, if y is -2, then x is -2. So if x is -2, y is -2. X is -1, -1, so forth. You graph that, you can get your points, boom, boom, and you got your parent function, your linear parent function. Okay? Now, it says when you change the slope, so when we change m, it changes the slant of the line. And you can look down at the bottom of your notes. Your options are, it's going to be steeper, it's going to be flatter, or if you change it from a positive to a negative, it's going to be reflected. It goes from a positive slope to a negative slope. Okay, number 2 says, how is the parent linear function, so the line that we have graphed up here, how is this line changed if the slope is changed to 1/2? Okay, so what we're saying is we originally had a slope of 1, and we're changing that to a slope of 1/2. If the slope is smaller, so we went from 1 to 1/2, it got smaller, the line is going to be flatter. The line would be flatter. So if your slope gets smaller, then the slant of that line, the steepness of that line is going to be flatter. Now, what about if we change the graph, if we change the slope of y equals 2x minus 1 is changed to 7. So let's look at this. Look at your equation. Y equals 2x minus 1. Your slope equals 2, because again, mx plus b, there's your slope. And if we change that to a slope of 7, it went from 2 to 7, it got bigger. And if it gets bigger, then your slope, the slope of your line is going to be steeper. If your slope gets bigger, then you're going to have a steeper line. All right. Describe the changes from, and it gives you 2 equations. So in the first one, my slope is 1/3. And then we're changing it to where my slope is, and on this one, it's -2. It's -2. Okay, if we change the sign, so we went from a positive to a negative. So if we change the sign, so we went and it changed it to a negative, then that line is going to be reflected. And 2 is bigger than 1/3. Just look at the numbers. Don't look at the sign, look at the numbers. 2 is bigger than 1/3, so it got bigger. And if it gets bigger, we just said up here, if it's bigger, it gets steeper, so it's also going to be steeper. So it's going to be steeper, and it's also going to be reflected. All right, and again, here's your. I start it for you, and this will tell you what's going on. If m is bigger, it's going to be steeper. If m is smaller, if m is steeper, it's going to be bigger. If m is smaller, it's going to be flatter. If it goes from a negative to a positive, or if m is negative, it will be reflected. And what that looks like, if this was my slope of my line, if it's negative, now my line would look like this. And you know that, we've seen that. Okay, so that's the first set of notes. That's when we change m. Go ahead and go to the next page. I'm just going to keep going on this video. In the next page, we're going to talk about what happens when you change b. So here we go on the next set of notes that we have. At the very beginning, it talks about what we just talked about on the last set of notes. A proportional relationship has the following qualities. It has remember, there's two things. It has a positive slope, and it goes to the origin. Okay, and another name for a proportional relationship is direct variation. So if you hear direct variation, that's the same thing as a proportional relationship. And all it means are these two things right there. It's positive, and it goes to the origin. All right, number one, Melinda is driving home at a speed of 80 kilometers per hour. Her distance from home is shown on the graph. All right, so it gives us the graph, and it says, what is the y-intercept of this graph? Oh, come on, boys and girls, let's go now. Here we go, y-intercept. There it is right there. There's my y-axis. That's at the point 0, 400. It's at 400. Okay, what would happen to the graph if the y-intercept were increased by 40? So if we increase this y-intercept by 40, that means we would go up 40, which would be right. I'm gonna get a different color. Which would be right here above 400. Your line would still have the same slope. All you would be doing is shift it up. So right here, what's happening is, that's an I. We would shift up 40 units. If we increase the y-intercept to 40, we shifted the whole line up. Okay, what would increase of 40 mean in our situation? Well, we started at 400, so that means that she would start not at 400, but at 400 plus 40 would be 440 kilometers. And again, it's distance from home, so it should be 400 kilometers from home. That's what that would mean. She's further away from home. All right, if the y-intercept were halved, what would the new y-intercept be? So we're saying, okay, here's my y-intercept at 400. If I cut that in half, it would be 200. Oh, let me get another color. Go green. 200. Cut it in half. So my y-intercept at 200, what would be the effect of the graph? Well, it's the same thing. We would be shifted, not up this time, but shifted down. And how far did we shift down? We went from 400 to 200, so it went down 200. All right? What would this mean in our situation? It means she would, again, the same thing. She'd start. Now she'd be 200 kilometers from home. Again, nothing changes with the slope. We're not talking about, the slope would be exactly the same. So these slopes would all be the same. I know that was kind of bad right there. That's kind of bad. But all the slopes, nothing happens to the slope. Nothing at all happens to the slope. It's just a matter of where it starts. So this says Ronnie drives home at the same rate as Melinda, but he lives 300 kilometers away. Described how the graph was changed. So if we're going to graph Ronnie here, it said he's 300 kilometers away. Oh crud, I'm just going to use black. 300 kilometers away, so he would start at 300 kilometers. He'd start at 300 kilometers. His slope would be the same. Okay, so what changed from the very beginning when we started at 400? Now we're shifted down 100. Because we started at 400, and it says he was at 300, so we were closer. We shifted down 100. Does this graph represent a proportional relationship? Give evidence to support. Okay, proportional relationship. Go back and look at the top of your page. Proportional relationship. Right there. Proportional relationship. it says it's a positive slope and it goes to the origin. Look at our graphs. Look at the graph right here. Are these positive? No, they're not positive. No, they don't go through the origin. So does it represent? No, it doesn't. You can write that out. It's not positive, not through the origin. Okay, here we go, last page, y'all stay with me. Stay with me. Here we go, last page. I'm going to go back to my red. All right. Here we go. This is the same kind of setup as the last set of notes. Again, parent function is y equals x. -2, -2, -1, 0, 1, 2. They're the same thing because y equals x. It's the same thing. Your slope is equal to 1. Your y-intercept is equal to 0. So if we were to graph this, and I know this graph is very small, you'd be going up by, again, it's the same thing. You'd be going up by 1, so you could graph it. Okay, so here we go. When you change the y-intercept, or b, when we change the b, it changes the starting value of the function. Okay, so let's look and see. Now, how would the graph of y equals 4x minus 1 change if the y-intercept was changed to -5? So, in the first part, my y-intercept is right here at -1, so it's -1. And then we're changing it to where my y-intercept, and it tells us, oh my gosh, that's terrible. It tells us it's -5. So we went from -1 to -5. So from -1 to -5, it got smaller. Okay. And so if it gets smaller, that's where we shift down. We shifted down. And how far did we shift down? From -1 to -5, we shifted down 4. So if the number gets smaller, we shift down. If the number gets bigger, we shift up. So again, what is the effect on the graph of y equals 2x minus 3 if the new equation is y equals 2x plus 1? So y-intercept is plus 1 plus minus -3. So we started with b equals -3. We went to b equals 1. So it went from -3 to 1, so it got bigger. And if it got bigger, that means we're going to shift this whole line. The line, we're going to shift up. And how much? -3 to 1, so that's up 4. So we would shift up 4. All right? Again, that was when it was bigger. So if b is smaller, then we shift down. If b is bigger, then we shift up. Number 4 says y equals x minus 4. What is the new equation? If the y-intercept has been decreased by 4. Decreased. That means we're going down 4. So my y-intercept right here is -4. So I'm going to start with -4. And then it tells me we're decreasing by 4. So I'm going to take -4 and I'm going to subtract 4. Well, -4 subtract 4, what is my new y-intercept going to be? You guessed it, -8. -8. So my equation would be y equals x minus 8. Okay, and again, start it. We can shift, when we change b, if it's bigger, we shift up. If it's smaller, then we shift down. All right, we have the notes. We'll be going over these tomorrow, working on the assignments. Thank you guys, and we'll see y'all. Have a good evening.